Okay, Assalamu alaikum, my dear students. Today we are in mechanics session LO 2.07. Our title is Conservation of Momentum Collision. I wish you are happy today. Listen carefully. Collision and momentum. You already have momentum before. Our object is to be able to use the concept of rate of change to justify mathematically that changes in momentum equals impulse. Change in momentum equals impulse. This is a Colorado education site. You can use it anytime. Okay. Conservation of momentum. In the absence of external force, the momentum of a closed system is conserved. In the absence of external force. Closed system means what? A system that has no gain nor loss of mass. No gain, no loss of mass. Isolated system. A closed system with no net external force acting on it. It's clearly internal and external forces. Internal forces act between objects within a system. External forces are exerted by objects outside the system. Conservation of momentum. In a collision between two objects, momentum is conserved. Total momentum stays the same. Total momentum stays the same. Means what? Means total momentum before the collision equal total momentum after the collision. This means that in an isolated system, momentum remains constant. Momentum remains constant. Law of conservation of momentum. Whenever two isolated unchanged particles interact with each other, their total momentum remains constant. Okay, total momentum remains constant. P1 plus P2 equal P1 dash plus P2 dash. Means M1 V1 plus M2 V2 equals M1 V1 dash. V1 dash is the velocity after impact, plus M2 V2 dash, the velocity of the second mass after impact. In some conditions, maybe after impact, the two bodies are one body and moves as one body. Then M1 V1 plus M2 V2 equal M1 plus M2 V dash. We have many types of collisions. Elastic, inelastic, perfectly inelastic. Elastic, this is the two bodies are before collision and then after collision they separated or one moves far of the other. In perfectly inelastic, the two bodies before and after they may be one body. Types of collisions. Collisions connected with kinetic energy conserved, momentum conserved, stick together. Inelastic, kinetic energy conserved, momentum conserved, they didn't stick together. Inelastic, same kinetic energy converts to thermal energy and the momentum conserved and they didn't stick. Perfectly inelastic, Kinetic energy doesn't conserve, momentum conserved, they stick together. Elastic kinetic energy is conserved. This is in elastic collision. Inelastic kinetic energy is not conserved. Deformed objects stick together. Note that this is very important. Momentum is conserved in both types of collision, in elastic or inelastic. Elastic collision, if the deformation doesn't occur, heat is not generated and there is not loss in kinetic energy, then m1 v1 dash plus m2 v2 dash equal m1 v1 plus m2 v2. The sum of the two moments after collision directly equals the sum of the two momentums before collision directly. If two smooth poles collide, then the sum of their two moments doesn't change due to collision. This is in the case of a smooth pole. Algebraic measures can be used to as follow: m1 v1 dash minus m2 v2 dash v1 equal negative I. I is the impulse. m2 v2 dash minus m2 v2 equals the impulse. m1 v1 dash plus m2 v2 dash equal m1 v1 plus m2 v2. Since I is the algebraic measure of the impulse of the second ball on the first ball, v1, v2 are the algebraic measure of the velocities before collision. v1 dash, v2 dash is the velocities after collision. The direct collision, the two velocities before and after collision directly are parallel to the line of the two centers of the moment of collision. Maybe spheres, maybe cars, maybe anything. Inelastic collision, the inelastic collision is meant that a deformation takes place. Heat is generated or the bodies get connected due to the collision process. Loss of kinetic energy occurs, maybe. In spite of it all, the momentum after and before collision remains and it's without change. And the momentum conservation equation is formed in case the two bodies connected. I told you before, m1 v1 plus m2 v2 equals m1 plus m2 v. Before equal, after collision they become one body, then they have the same velocity. Okay, the same first case is in the vector form, second case is in a scalar form. Okay, do you know this is a scissor in American football? Examples of perfectly inelastic collision: catching a baseball, football tackle, cars collision, colliding and sticking, bat eating an insect. Example of perfectly elastic collision: super pole bouncing, electron scattering. Two smooth poles, each of mass 200 gram, moves in a straight line. Two smooth poles, each of mass 200 gram. Okay, then they are equal in mass. In a straight line, on a smooth horizontal plane, there is no friction. The first with velocity 4 meters per second, and the second with velocity 6 meters per second. This is V1, this is V2, and M1 as the same for M2. In the same direction of the first ball. If the two balls collide, identify the velocity for each of them directly after collision, given that the impulse magnitude of the second ball on the first is equal 5 times 10 power 4 by second. What do you think? Yes, we can see. Here is the two balls, 2 gram, 200 gram, and second 200 gram. The first one is velocity 4 meter per second. Second one is 6 meter per second. Okay, they collide together. The impulse of the second ball on the first ball is in positive, I equal 5 times 10 power 4. The second impulse is negative, okay, of the second ball. And with respect to the first ball, I equal m1 v1 dash minus v1, and then v1 dash is 6.5 meter per second. With respect to the second ball, I equal m2 v2 dash minus v1 minus v2, then negative 5 times 10 power 4 equal to 100 times v2 dash minus 600. 600 with is what is the velocity of the second ball. We have here is 6 meter, and we have is gram, and we want to deal with centimeters, then we change it to centimeter. Then v2 dash, it will be 350 meter centimeter per second, then it's 3.5 meter per second. Then the first one, its velocity after impact is 6.5. It was 4 meter. And second one is 3.5. It was 6 meter per second. Then its velocity is reducing. The two balls moves directly after the collision in the same direction. The first with velocity 6.5 meter per second, and second with velocity 3.5 meter per second. These rules can use in some accident in highway. Two balls of mass 100 gram, 50 gram moves differ in mass. Moves in a horizontal straight line in two opposite directions. The two poles collide when the velocity of the first was of magnitude 50 centimeter per second. Then this is v1. And the velocity of the second was of magnitude 30 centimeter per second. This is v2. If the second pole responded back directly after collision with velocity 40 centimeter per second, then if the first direction of velocity is positive, then the second direction is negative. Find the magnitude and the direction of the velocity of the second pole directly after collision, and the impulse magnitude for any of the two poles on the other. I will give you 5 minutes to think about, and then we will discuss it together. Okay, this is the Ferris ball, this is the second ball, this is 100 grams, this is 50 grams, this is the Ferris, this is the second. They, as you see, moves in opposite directions towards, and after collision, as you see, the hose will be repelled Yes, which is reports the second ball, because the second ball is 50 and the first ball is 100. And let the direction of the velocity of the first ball before collision in the direction of the unit vector c. This is the vector c. The sum of the two moments before collision equals the sum of the two moments after collision. Then m1 v1 plus m2 v2 equal m1 v1 dash plus m2 v2 dash. 100 gram times 50. 50 is the velocity of the Ferris, minus m2 is 50 times 30. Negative here is the direction of v2. This is the positive direction, then this is the negative direction. After collision, this is the same direction, and this is with c, then it will be positive. Then 100 gram v1 dash plus v50 times 40. 40 is the velocity after collision. Then we can find the velocity of the first ball after collision, which is 15 centimeter per second, and this is positive, then in the same direction of c, and this is someone asked why this is the positive direction. You can use this as a positive direction, but I think we use it in the direction of the big mass. Okay, or greater mass. But it's up to you. Second, we find the impulse of the first ball on the second ball. The impulse of the first ball on the second ball equals the change of momentum. Then, don't forget, the impulse is the change of momentum, and you already have it in physics. I know. I equal m v2 dash minus v2. Then it will be 350 grams per second. This is another one. A train car of mass 10 tons moves with velocity 20 meter per second. 20 meter per second is a high velocity. It collides with another train car at rest. This is car is at rest of mass 10 tons. Okay, what do you think? It must be moves as the same body. If both cars moves directly after collision as one body, calculate their common velocity at this moment. Okay. Okay, do you hear the train? Yes. Let the mass of the moving car be m1. Then m1 it will be 10 tons. Second, its velocity is 20 meter per second. Let the mass of the car at rest is 10 tons. It says 10,000 kilogram with velocity 0. Yes. Consider the velocity of the first body before collision is positive, and the common velocity of the two bodies directly after collision is v. Okay, the sum of moments before collision equals sum of moments after collision. I think you already understand it. m1 v1 plus m2 v2 equals m1 plus m2 times v. m1 is 10,000 kilogram times its velocity, which is 20 meter per second. m2 is 10,000 times 0 equals the sum of the two masses times v. Then v is 10 meters per second in direction of the motion of the first car. This is an easy one, and don't forget this sound. The train sound, I love it. Okay, this is another example. We have an iron hammer. This is the hammer of mass 210 kilogram. It's too heavy. Falls down from a height of 90 centimeters. This is not an ordinary hammer. It's something like in machines or something like that. It falls down from a height of 90 centimeters on a foundation ball. This is a foundation ball of mass 140 kilogram. Okay, this is of mass 140 kilogram. What do you think? To push it in the ground for a distance 18 centimeters. This is the ground, and this is hammer. Falls down from height 90 centimeter. It's collide with this foundation ball and pushes it in the ground for a distance 18 centimeters. If the hammer and the ball moves as one body directly after collision, find the common velocity of each, then find in kilogram weight the average of the ground resistance, supposing it is a constant. When the hammer falls down on the foundation ball, they goes inside the ground, but they didn't move forever because the ground has resistance. Then it will stop their motion. We will discuss how much they common velocity of each, and also find the average resistance of the motion. Okay, this is the hammer stick zababa. Okay, sorry. First of all, the hammer has initial velocity and is 0. We have 9.8 meter per second square. This is the gravity, and it moves 9 centimeter, as I told you before, and I always told you dynamics units is very important. Please take care of units. Then V naught is 0. V square equal V naught square plus 2gs. This is a kinematic rules. V square equal 2 times 9.8 times 0.9. 9 centimeter divided by 100, it will be 0.9. Then the final velocity is 4.2 meter per second after taking square root. This is the initial velocity for the second stage. They will move together with the say as one body. Okay, what do you think? After collides the hammer with the pole and they penetrated in the ground, okay, they have to stop. Then it's their final velocity. It will be, who can tell me? Okay, very good. It will be 0, right? Because there is a resistance. Very good. What do you think in the ground? Does we use 9.8 or something else? If you remember in grade 10, okay, if a ball penetrated in a pool, water, In the space, it will be 9.8. Yes, the Earth's gravity. Down the sea surface, there is an acceleration. Very good. Okay. And you have many examples in grade 10 about it. Yes, let us see. Then, after collision, M1 V1 plus M2 V2 equal M1 plus M2 times V. M1 is 210 times 4.2. M2 is 140. It was at rest equals M2 times V. Then V, it will be 2.52. This is the velocity when they move together. After collision, the two bodies are one body moving with acceleration, as I told you, for a distance 0.18 meter, and initial velocity is 2.52 meter per second. And this final velocity, yes, as you told me, is 0. Then V square equal V naught square plus 2AS, not 2GS. Then final velocity is 0. Their velocity is 2.52 power 2 plus 2 times A times 0.18. Then we will find A, which is the acceleration on the ground. It will be 17.64 meter per second square. To find the average of the ground resistance, then the net force is M1 plus M2G, the mass of the hammer and the foundation pole, minus resistance of the ground equal MA. M is the total mass of the two bodies. M1 plus M2 times 9.8 minus R equal 350 times the acceleration, which is negative 17.64. Then the resistance, which is 35 times 9.8 plus 350 times 17.64. Then the resistance is, yes, 9,604 newtons. To convert to kilogram weight, we will divide it by 9.8. It will be 980 kilogram weight. Okay. Another example, this is for you. An object with a mass of 9.39 kilogram is moving with a velocity of 6.65 meter per second. It sticks a stationary 8.8 centimeter kilogram object, and the two sticks together. The two stick together, moving off as one object. What is the mutual velocity? Sorry. What is the mutual velocity? Then an object with a mass of 9.39 kilogram is moving with velocity of 6.65 meter per second. It sticks a stationary 8.83 kilogram object, and the two sticks together, moving off as one object. What is the mutual velocity of the two objects after collision? This is an easy one. What do you think? Yes, 3.42 meter per second. M1 V1 plus M2 V2 equal M1 plus M2 times V. Very good. We have here M1, we have here M2 V1, we have here M2, we have here This is M stick together, stationary 1, M2. Then we can find, and this is stationary is V2 is 0, and this is an easy. Another one, a stationary 9.96 kilogram object is struck by a moving body 7.56. They stick together, moving off with a mutual velocity of, here is the mutual velocity. What is the original velocity of 7 point? That's an easy one. This is V1 equals 0. This is V2, which we want to find it. Okay, you can find it will be number A. Okay, another example. A stationary again, object 12.57 kilogram object is struck by a moving object of unknown mass. Here is M2 is unknown with a velocity. This is V2. They stick together, moving off with a mutual velocity. This is V. What is the unknown of them? This is an easy one. M1 V1 plus M2 V2 equals M1 plus M2 V. Here we have is EV, which is 17.6 meter per second. V1 equal, yes, 0. M1 equal 12.56. Unknown mass, M2 we didn't know it. V2 is 38.58 meter per second. Then this is an easy example, direct solution. And the answer is C. An object with of mass 16.51 kilogram is moving with a velocity 10.87 meter per second, M1 V1. It tracks a 14.03 kilogram object from behind that is moving at 4.94 meter per second. The two sticks together, moving off as one object. What is the mutual velocity? This is another one. Another one, a 17.64 object moving with velocity 5.52 meter per second, struck from behind with 6. Okay, this is an easy B. And this is another one, a 9.57 object is moving at 3.62, is struck from behind by a moving object of a known mass that is moving with a velocity 27.99 meter per second. They stick together, moving off with a mutual velocity. This is V. What is the unknown mass? This is an easy one. It will be number B. And here is another one, the same. You can solve it. An object of unknown mass, 2.2 meter per second velocity, struck from behind by 7.43 kilogram object that is moving with a velocity of 34.65 meter per second. They stick together, moving with